This video is about how to determine whether the function has an inverse function, and then how to find the derivative of an inverse function without finding the inverse of the function. When the function f has inverse function, a function f has an inverse function if and only if it is one-to-one. Now the question is, what is one-to-one function? Well, if f is strictly monotonic on this entire domain, that is, f is either monotonic increasing or monotonic decreasing over its entire domain. So in this figure, this is monotonic increasing, and here is what monotonic decreasing. So both of these are one-to-one function, and both have the inverse function. Horizontal line test. We can also use horizontal line test to find out if the function has inverse or not. So a function has an inverse function if and only if every horizontal line intersects the graph of f at most once, no more than once. So the function f of x shown in this figure, this one, has no inverse because horizontal line intersects the graph at 3 points, which is more than 1 point. How to find whether the function is monotonic or not using derivative. So the function f is strictly monotonic and has inverse function if the first derivative is greater than 0 on its entire domain, or f first derivative is less than 0 on its entire domain. Here's an example. So we have a function f of x equal to natural log of x minus 3, and we're going to find whether this function has inverse function or not. So first we identify the domain, and for the logarithmic function, to find the domain, you take the argument x minus 3 and set greater than 0, and then solve for x. So this gives you x greater than 3, which means 3 to infinity, that's the domain. Now we differentiate the function, and the derivative of natural log of x minus 3 is 1 over x minus 3. And now we test the first derivative for x bigger than 3. So let's say if I use x equal to 4, so f prime 4 is 1 over 4 minus 3, which is 1 greater than 0. So we can say function is strictly monotonic and function has inverse. How to find the derivative of inverse function? So let's say f be a function that is differentiable on an open interval I. If f has the inverse f minus 1, then f negative 1 is differentiable at any x for which first derivative evaluated f inverse of x is not equal to 0. And the derivative of f inverse is given by 1 over the first derivative evaluated f inverse over x. So let's say here's an example 2. We're going to use the function f, and it's given real number a equal to 7 to find the first derivative of inverse function evaluated at a. So here f of x equal to 4 minus 3x cubed and a is 7. So step 1, first check if f of x is monotonic on this domain. But first we need to know what is the domain. So we know f of x equal to 4 minus 3x cubed, and this is polynomial function, and we know the domain of polynomial function is all real numbers. In the interval form, you can say minus infinity to what? Infinity. So let's find the first derivative of the given function. So the derivative of 4 is 0. So and the derivative of negative 3x cubed is negative 9x squared. Now we set the first derivative 0, which means we set negative 9x squared equals 0 and solve for x. So if you can divide by negative 9 gives the x squared equals 0, and then you take the square root, the x equal to 0. So clearly x equal to 0 is the only solution. And that is the critical value of the function. Now we're going to test the first derivative minus 9x squared for increasing and decreasing for the values smaller than or less than 0. So to do that, we're going to pick any value that is less than 0. So let's say x equal to negative 2. So we substitute in the first derivative f prime x equals to minus 9x squared. So we get f prime evaluated at negative 2 equals minus 9 the square of negative 2 is 2. Well, square of negative 2 is 4, and 4 times negative 9 is negative 30, which is less than 0. So we can imply that f prime x is less than 0. That is, f of x is decreasing for all x values less than 0. Now we're going to test f prime x equals to minus 9x squared for increasing and decreasing for the values x bigger than 0. So now pick any x value that is larger than 0. So let's say we can pick x equal to 2 and substitute in the first derivative f prime x equals to minus 9x squared. So this becomes the first derivative evaluated at 2 equals to negative 9 times 2 squared. Again, 2 squared is 4, and multiply with negative 9 gives you negative 36, which is less than 0. So we can imply that the first derivative is less than 0. That is, f of x is decreasing for x greater than 0. So we already determined the f of x is decreasing for x less than 0. Now we are determining that f of x is decreasing for x bigger than 0. So we can make conclusion that f of x is decreasing over an entire domain, negative minus infinity to positive infinity, which means it's a monotonic decreasing. Since the function is monotonic decreasing, we can say this f of x has an inverse function. Or you can say the f of x is invertible over its domain. Now since f of x equal to 4 minus 3x cubed and a7 is invertible, we proceed to the next step. So step 2, we're going to find the x value by solving f of x equals to a equals 7. So we have now equation 4 minus 3x cubed equals to 7. So to solve for x, we're going to move 4 to the right and becomes 7 minus 4, which is 3. And then we divide by negative 3. So you get x cubed equals to 1. And we take the cube root and then x equal to 1. So now we proceed to the last step, 3. So note that the x is f inverse evaluated at a is f inverse of 7. We just found 1 in step 2. So now we need to find f prime x of f of x, which is f prime x is negative 9x squared. Now we substitute the x value in this one. So we get f inverse evaluated 1 is minus 9 times 1 squared. 1 squared is 1, so it will be negative 9. Now we use the formula f inverse, derivative of f inverse evaluated at a is 1 over the derivative, first derivative of f evaluated f inverse A. And we know f inverse A is 1. So derivative of inverse evaluated 7 is simply 1 over the first derivative evaluated at 1. And which we already found the f inverse 1 is minus 9. So this becomes 1 over minus 9. That is negative 1 over 9. And that's the answer. Example 3. We're going to use the function f and the given real number a to find the derivative of f inverse evaluated at a. So here f of x equal to x plus 6 over x minus 2, and the domain is x bigger than 2 and a is 3. So first we step check if f of x is monotonic on its domain. So here's the function f of x equal to x plus 6 over x minus 2, and the domain accordingly is given 2 to infinity. So now we're going to find the first derivative using the quotient rule because this is quotient. And so this becomes f prime x, and the quotient rule says you square the denominator x minus 2. So this becomes x minus 2 squared. And then we'll write the denominator x minus 2 and multiply the derivative of the numerator, which is x plus 6, and minus, we write the numerator x plus 6 and multiply with the derivative of x minus 2. So now we have x minus 2 and derivative of x plus 6 is simply 1 because the derivative of 6 is 0. And minus x plus 6 and the derivative of x minus 2 is also 1. So now we simplify to this becomes x minus 2, and this minus is going to change all the signs, and we get minus x minus 6. Now x and minus 6 cancel out, and minus 2 and minus 6 become minus 8. So the first derivative is negative 8 over x minus 2 squared. Now the first derivative of f of x is equal to negative 8 over x minus 2 squared. So we pick any x value in this interval 2 to infinity, and we can clearly see that if whatever number you put this one becomes positive and this is negative, it's going to be always less than 0. So we can conclude that f is monotonic and inverse exists. So now go to step 2. We're going to find x using f of x equals to a, and a is given 3. So f of x is x plus 6 over x minus 2. So we're going to set x plus 6 over x minus 2 equals to 3 and then solve for x. Well, in this is a rational equation. We multiply both sides by x minus 2. So this becomes x minus 2 times x plus 6 over x minus 2 is equal to 3 times x minus 2. Now x minus 2 cancel with x minus 2, and you're left with x plus 6 equal to 3 times x is 3 times x is 3x minus 3 times 2 is 6. Now it's a linear equation, and we can move the 3x to the left side and 6 to the right side. So we have x minus 3x, and we have a 6 minus 6, and that's also minus 6. So minus 6 is minus 12. So x minus 3x becomes negative 2x. Now we divide by negative 2. So this will give you x equal to negative 12 or negative 2, which is 6. So now we are on the step 3. We substitute x equal to 6 in the first derivative, f prime x equal to minus 8 over x minus 2 squared, which was obtained in step 1. So this becomes f prime evaluated at 6 equal to negative 8 over 6 minus 2 square. And 6 minus 2 is 4, so we have a negative 8 over 4 square. 4 square is 16, so we have negative 8 over 16, which is negative 1/2. So the last step, the derivative of prime evaluated at 3 is equal to 1 over function evaluated at x value, which is 6, f prime x, and we just found f prime x is negative 1/2. So we have 1 over negative 1/2, which means we multiply 1 with the reciprocal of negative 1/2, which is negative 2 over 1, which is negative 2. So the answer is negative 2.